So let's look at an example. So if we have, for example, the integral from, let's say, 0 to 4, from e to x squared dx, don't try to determine the antiderivative. You will not be able to. Can you get this number with a calculator? Probably. But you will not be able to determine the antiderivative. It's not possible. We don't have tools to determine the antiderivative of this function. So I may ask you to use 4 subintegrals and approximate the area, which is fine. So you can use the leftmost point or the rightmost point. I may indicate the right, let's say. So if we indicate the rightmost point, this is 0, 1, 2, 3, 4, 1, 2, 3. So we're asked to use 4 subintervals. Then the width of each subinterval, that's very nice, is just 1. If I'm asked to use the rightmost point, I have to use only the height at 1, 2, 3, and 4. If you add the 0, it's incorrect. Because this is the base times the height where the function stops. Plus base times the height. Plus base times the height. Plus base times the height. Only 4. So very convenient because the base is 1. I don't even have to take it into account. But if the base is 2 or any other number, I have to take it into account. But in this case, I will immediately say that this is approximately base times height, f of 1 plus f of 2 plus f of 3 plus f of 4. All I have to do is just plug these numbers in the calculator and get the sum. So we may get huge numbers. We'll see in a moment. So here's how I would do it, as I showed it in class. So I'll go to stats. I'm going to edit, like I showed you with the linear regression. Clear, clear, highlight the top and clear. And then I will plug in just exactly what I have. 1, 2, 3, 1, 2, 3, and 4. And what I like to do, although you don't have to do this, this is E. And the power is list L1 squared. That's all. And when I click enter, this is what I get. Huge. 8.89 times 10 to the 6th power. It's going to be a huge number. But that's okay. And then I go to stats. And I just do one variable stats because I don't want to do this by hand. Can you do it by hand? Yes. So here is, so I did list L1 by mistake. I don't want, who cares about list L1? I care about list L2. That's where the function values are. Okay, so look at the number. The sum is 8,894,270.921. Huge, as expected. 894,270.92. That's the approximate. Can you try? I'm even scared to try, but why not? It cannot be the same number. We are approximating using 4 subintervals. You can imagine it's a rough estimate. It could be close. We'll see. So E raised to power x squared. It may not be able to calculate. It may give us a totally different number. We'll see in a moment. Moment of truth right now. Boom. It may take, yeah, it gave us some 1,149,400. So you can say, but what about that 8 million? Well, we expected to have error. We only used 4 subintervals. the calculator calculated only what is exactly under the graph. No overestimation, no underestimation. Okay? You can check, but as I said, don't rely on this, because this is the exact. And we can never find by hand, we can never find the antiderivative of this. We can find an antiderivative of e to the x, or e to 3x, but not e to x squared. Okay, very good. That was approximating areas. Very simple. You're going to have only 4 subintervals, and I will indicate leftmost point or rightmost point. Be very careful. Circle what you need, so you don't start from 0. Now, if the question is asking using the leftmost point, then you have to use this and this and this and this, not the last one. You have to use 4. F of 0 plus f of 1 plus f of 2 plus f of 3. Only 4. So count them several times so you don't make the error of adding the fifth one, or 5 subintervals. Very good question. Any questions you have on this? Any questions, or is it clear? Okay, let's choose the next topic. Anything you want, you choose. Yes, those are the ones that we discussed yesterday.
Oh, then never mind.
This is when we graphed and we found the points of intersection and we shaded in the area and we determined it. That's fine. Whatever. Do we want to do that, or should we choose an example? Anyone? Yes?
See an example.
Very good. So these are from chapter 4. I'm looking at the page number. I just need the page. That was, I think, in 4.4. Yes, page 425. So these are the examples, 15 to 33. So please feel free to choose any problem. Remember, the requirement is graph, find points of intersection, shade in the area, and calculate the area. Anyone would like to pick, or I will?
I'm good with whichever one you select.
Okay, well, in that case, I have no idea. I'm going to select 28. That's my page 5. Is 28 okay? 28. Y equals 4 minus x squared. Y equals 4 minus 4x. So remember, I have to graph, and I have to find the points of intersection. Why don't I start with the points of intersection? I set them equal to each other. So 4 minus x squared equals 4 minus 4x. Nice. I have 0 equals, I move this term because it's negative. And I factor out x, and I have x minus 4. So I have 2 points of intersection, x equals 0, y equals 4. So 0, comma 4. And x equals 4. 4 minus 16 is negative 12. So 4, comma negative 12. When I graph this, remember this is a parabola, either opening upwards or opening downwards. Well, because the leading coefficient is negative, it's not going to be this, it's going to be this. Remember from the previous class, transformations. If I graph x squared, I get this, but I have to graph negative x squared, so I will get this, and then up 4. 4. So it crosses at negative 2 and 2. So I have the first graph. I always need the vertex and x and y intercepts. So this is the first graph. Y equals 4 minus x squared. Because I went ahead and I found the points of intersection, I know that 0, 4 is this point. And 4, negative 12 negative 12, 4. Sorry, of course, 4, negative 12. So when I graph y equals 4 minus 4x, when x is 0, y is 4. And when y is 0, x is 1. And you can say, what's going on here? Well, I have to extend this graph. This is the area in question. Above minus below, from 0 to 4. From 0 to 4. Above, which is 4 minus x squared, minus below, minus 4 plus 4x dx. This is the above, 4 minus x squared, minus this. When I distribute negative 1 to 4, I get negative 4. And when I distribute negative 1 to negative 4x, I get positive 4x. These two luckily go away. So then I have negative x to the third over 3 plus 4x squared over 2 from 0 to 4. Luckily, again, I don't have to plug in 0, but I still have to start with 4. So I have negative 64 over 3 plus, this is 2, and this is 16, so plus 32. 94 minus 64. 96, I'm sorry. 96 minus 64. So I think I get 32 over 3. And we will check this in a minute. So 96, is 96 minus 64 32? I think it is. Let's take a look at the graph. Make sure that we are correct. And let's calculate the integral, just double checking. So we go to the calculator. In y equals, I have the first function 4 minus x squared. I have the second function 4 minus 4x. And I know the intersection. So I could possibly use a viewing window, so it goes all the way to negative 12. So I'll change the viewing window. I don't need the left-hand side that much. So 4 to 10 would be okay with a scale of 2. But y minimum has to pass negative 12. So I'm going to say negative 20. And y maximum, I'm going to make it 6 with a scale of 4. So when I click enter, when I click graph, I have to see something like the parabola, the line intersecting it, and those 2 points of intersection. Otherwise, I have to go back to the drawing board and start from scratch. So x, of course, negative 4. Okay, here it's coming, yes. So this is the area in question, from x equals 0 to x equals 4. From above, which is 4 minus x squared, minus below, which is 4 minus 4x. I see the graph, I'm happy with my graph, I see that I'm correct, but now I just also want to check the integral. So I have math 9, and the integral is from 0 to 4. From above, again, 4 minus x squared, minus below, which is minus 4, and plus 4x, and of course dx. And when I hit enter, I have to go get 32 over 3. If I don't, I have to go back to the drawing board. So whatever that means, let's see if we can change it into a fraction. Yes, 32 over 3. Okay? Very good. Next question. Anything else you would like to go back to?